Everyone. In the previous class, we have discussed about problems on bilinear transformation, and the next concept is conformal transformation. In bilinear transformation, we transform a complex number into a complex function using given set of numerical values, while in conformal transformation, we have to transform a complex number into a complex plane geometrically or complex function geometrically. And we know that complex function is in the form of w is equal to f of z, and complex numbers are z is equal to x plus iy in Cartesian form or e power of I theta in polar form. And complex form of w is u plus iv. And we have a procedure to transform here. The working procedure is, first the given function is in the form of w is equal to f of z in a function form, that is complex function form. Then we have to write in form of complex, that is including real and imaginary part. W is equal to u plus iy in the place of z, x plus iy. And in most of the problem, we prefer Cartesian form of the complex number. If it is not possible to simplify in Cartesian form, then only we have to take polar form of the complex number. After substituting, we have to separate its real and imaginary part, and real and imaginary part must be the functions of x and y, and we have to consider the two equations as 1 and 2. After that, we have to form another two equations such that one equation contains u and v in terms of x. That means we have to eliminate y from first and second equation and consider that equation as 3 u and v in terms of x. And similarly, by eliminating x from the same two equation, we have to form one more equation in terms of y. After that, the last step is we have to consider two constants in z plane, that is x is equal to c1 and y is equal to c2. X is equal to c1 represent a vertical straight line in z plane, y is equal to c2 represent a horizontal straight line in the z plane. Corresponding to these two lines, we have to find the image of u and v in w plane. So let us consider the first one, that is w is equal to e power of z. Discuss the transformation w is equal to e power of z. So I solve w is equal to e power of z. The complex form of w is u plus iy, z is x plus iy. We have to substitute that. After that, keeping LHS as it is, by splitting the RHS, it can be written as e power x into e power of iy, and e power of iy is the complex form which can be written as cos y plus I into sin y. Then comparing its real and imaginary part, u is equal to e power of x cos y and v is equal to e power of x sin y. Consider the two equations as 1 and 2. Now after that, we have to form two equations such that u and v in terms of x, u and v in terms of y. For that, we have to simplify the same two equations. So while simplifying, we can take adding the two equations, subtracting the equation, or multiplying. You can take any simplification, but after simplification, y must be eliminated in the two equations. So in this problem, I am taking the simplification that squaring and adding 1 and 2. Squaring and adding 1 and 2, we get in LHS part u square plus v square. In RHS, e power x whole square cos square y, e power x whole square sin square y, which results in e power of 2x. So because we know that cos square y plus sin square y is equal to 1. So remaining term is e power of x square, which can be written as e power of 2x. So that is the first equation, that is u and v in terms of x. Next, to find one more equation, I am dividing second equation by first one. So then v by u is equal to sin y by cos y. Sin by cos results in tan y is equal to v by v, which results in u and v in terms of y by eliminating the x term. Now we have to consider two constant, x is equal to c1, c2, which represent the straight lines in z plane. Corresponding to this c1, c2, we have to find the image of u and v in w plane, considering equation number 3 and 4. So I am considering two cases here. First case for x is equal to c1, second case for y is equal to c2. In first case, x is equal to c1 in equation number 3, because in 3 y is eliminated. I'm considering equation number 3, and we get u square plus v square is equal to, equation number 3 is u square plus v square is equal to e power of 2x. In the place of x, I'm substituting c1. You get e power of 2c1. It can be written as e power of c1 square. And this is in the form of x square plus y square is equal to r square, which represent a circle with center origin, where e power of c1 represent a radius of the circle. Next, considering the second case, substituting y is equal to c2 in equation number 4, and we have equation number 4 is v by u is equal to tan y. In the place of y, we are substituting c2. Then v by u is equal to tan c2, and which can be written as v is equal to u into tan c2, which is in the form of y is equal to mx, which represents a straight line, where tan c2 represents slope of the straight line. V is equal to u into tan c2 is a straight line in w plane. So that means if x is equal to c1 in z plane, maps into a circle in w plane, and y is equal to c2 in z plane maps into a straight line in w plane. So writing its graph, in z plane I'm considering both the constants, that is x is equal to c1, y is equal to c2 in z plane. So corresponding to c1, corresponding to x is equal to c1, we have a circle, that is u square plus v square is equal to e power of c1 square in w plane. So this is the w plane. And corresponding to y is equal to c2 in z plane, there is a straight line passing through the origin in w plane with the equation v is equal to u into tan c2. So this is the transformation of e power of z. This is the transformation of w is equal to e power of z graphically. So x is equal to c1 in z plane maps into a circle in w plane. Y is equal to c2 in z plane maps into a straight line in w plane. So main conclusion is the line x is equal to c1 in z plane is mapped into circle, and y is equal to c2 is mapped into a straight line in w plane. Thank you.